66 million years ago, a rock the size of Mount Everest slammed into Earth at 20 kilometers per second. The explosion vaporized part of the planet, but here's what most people don't know. That blast didn't kill the dinosaurs. What came after did. The global firestorm that ignited every continent at once. The mega-tsunami, 300 feet high, that erased coastlines. The years of freezing darkness when the sun disappeared. The acid rain that poisoned the oceans. And the slow, agonizing collapse of the entire food chain that starved these massive creatures to death. This is the story of how one impact triggered a chain reaction of disasters that wiped out the dinosaurs and 75% of all life on the planet. Let's start at the very beginning. 66 million years ago, the Earth was a completely different place. Dinosaurs had been the dominant life forms on this planet for 165 million years. Just think about that number for a second. Humans have only been around for about 300,000 years. The dinosaurs had 165 million years of dominance. They were everywhere, massive creatures that seemed completely unstoppable, perfectly adapted to their world. And then everything changed in a single day. The killer was an asteroid about 10 kilometers across. To help you visualize this, if you've ever seen pictures of Mount Everest, that's roughly how big this thing was. A mountain-sized chunk of rock and metal floating through space, heading straight for Earth. But size wasn't even the most terrifying part. This asteroid was traveling at speeds between 10 and 30 kilometers per second. That's so fast that when it hit our atmosphere, the air in front of it couldn't move out of the way quickly enough. It compressed and heated up to the temperature of the sun's surface. Before it even hit the ground, it was already a massive fireball tearing across the sky. And then it struck. The impact site was the Yucatan Peninsula, in what we now call the Gulf of Mexico. When that asteroid hit, it created what scientists call the Chicxulub crater. The force of the impact was equivalent to billions of atomic bombs exploding at the exact same moment. The asteroid itself, the ocean water, and a huge chunk of the Earth's crust were instantly vaporized, just gone, turned into superheated gas and dust in a fraction of a second. Everything within hundreds of miles was killed instantly, but that was just the beginning. The impact blasted trillions of tons of rock, dust, and debris straight up into the atmosphere. We're talking about rocks the size of buildings being thrown into space, and what goes up must come down. Within minutes, all that material started falling back to Earth, but as it fell through the atmosphere, something terrible happened. All those tiny pieces of rock and molten material started heating up again from friction. They turned into superheated glass spherules, basically tiny meteors, and as they rained down across the entire planet, they generated this massive pulse of heat. The entire atmosphere turned into a broiler oven, and that heat was enough to ignite anything dry on the surface. Forests across North America burst into flames, then Europe, then Asia, then Africa. Within hours, massive wildfires were burning on every continent simultaneously. The world was literally on fire all at once. The smoke and ash from these global wildfires rose up and mixed with all that dust already in the atmosphere, creating this thick, dark cloud that started spreading across the entire planet. But the fire was just one part of the disaster. Remember, this asteroid hit with the force of billions of atomic bombs. That energy didn't just go up, it went through the Earth's crust as well. It created shockwaves that rippled through the planet, causing the most powerful earthquakes in Earth's history. We're talking about magnitude 10 or higher on the Richter scale. The ground shook so violently that it would have toppled ancient forests and split open the Earth. And if you were anywhere near a coastline, you faced something even worse. The impact in the ocean generated a tsunami, unlike anything we've ever seen in modern times. Scientists estimate this wave was around 90 meters high. That's about 300 feet, roughly the height of a 30-story building. And it was traveling at incredible speeds. This wasn't like the tsunamis we've seen in recent history. This was 30,000 times more powerful. It swept miles inland, erasing entire coastal ecosystems instantly. Anything near the water was simply wiped off the face of the Earth. So let's recap what happened in just the first few hours. A massive explosion vaporized part of the planet. Global wildfires ignited everywhere. The ground shook with unprecedented violence and a colossal tsunami destroyed all the coastlines. But believe it or not, all of that wasn't what killed the dinosaurs. The dinosaurs that lived far inland, thousands of miles away from the impact site, they actually survived all of this initial chaos. The blast didn't reach them. The fires eventually burned out in their areas. The tsunami didn't make it that far. They survived the worst day in Earth's history, but they were already doomed, and they didn't know it yet. Because high up in the atmosphere, that massive cloud of dust and ash and soot wasn't going away. Normal dust would settle back to the ground in a few weeks or months, but this was different. This dust cloud was so thick and so widespread that it blocked out the sun, and mixed in with all that dust was something even more dangerous: sulfur. You see, the asteroid happened to hit a spot on Earth where the rocks were rich in sulfur. When that rock vaporized, it created these tiny sulfur particles called aerosols, and these aerosols are incredibly good at reflecting sunlight back into space. They could stay suspended in the atmosphere for years. The result? The sun was blocked, not for days or weeks, for months, possibly years. The planet went dark, and the temperature dropped dramatically. Earth, which had been warm and lush for millions of years, suddenly plunged into what scientists call an impact winter. It was like a nuclear winter, freezing cold and pitch black. And this is where the real extinction began. Without sunlight, plants couldn't perform photosynthesis, and without photosynthesis, plants started dying, not all at once, but gradually, systematically, across the entire planet. The forests withered, the ferns died, the vegetation that had been abundant for millions of years simply disappeared. This triggered what scientists call a trophic cascade. Basically, the entire food chain collapsed from the bottom up. First, the plants died. Then the herbivores, the plant-eating dinosaurs, ran out of food. Creatures like Triceratops and the massive long-necked sauropods needed enormous amounts of vegetation every single day just to survive. These were the largest land animals ever, and they required a constant supply of food. But there was nothing left to eat. So the giant herbivores began to starve. Their size, which had been their greatest advantage for millions of years, suddenly became their biggest weakness. They were just too big to survive a famine. There wasn't enough food left on the planet to sustain them. And when the herbivores died, the carnivores followed. Predators like Tyrannosaurus rex depended on hunting those large herbivores. But once their prey disappeared, they had nothing to hunt. The mighty T-Rex, the apex predator that had ruled for millions of years, starved to death right alongside its prey. The age of dinosaurs didn't end with fire and explosions. It ended in darkness, cold, and starvation. But there was still one more killer lurking in the atmosphere. Remember that sulfur we talked about? When sulfur mixes with water in the atmosphere, it creates sulfuric acid. For years after the impact, the planet experienced constant acid rain, not just occasional storms. The entire weather system became acidic. On land, this acid rain poisoned the soil and killed off even more of the surviving plants. But the worst effects were in the oceans. The oceans absorbed so much of this acid that the water chemistry actually changed. And for any sea creature that builds a shell or skeleton out of calcium carbonate, like plankton, coral, and countless other marine species, this was a death sentence. The acidic water literally dissolved their shells faster than they could build them. The foundation of the ocean food web collapsed just like it did on land. When you add everything together, the initial blast, the global fires, the tsunamis, the earthquakes, the years of darkness and cold, the starvation, and the acid rain, scientists estimate that about 75% of all species on Earth went extinct. 3 out of every 4 species gone, including every single non-bird dinosaur. The planet was left cold, dark, poisoned, and nearly empty. So how did life come back? It took time, a lot of time. For months and eventually years, that dust and those sulfur aerosols stayed in the atmosphere, but very slowly they started to settle. The air began to clear, and eventually, after what might have been a year or 2, sunlight started reaching the surface again. The planet began to warm up, and life, incredibly resilient, started to return. The first plants to come back in a big way were ferns. Scientists can actually see this in the rock record, right after the layer of ash and dust from the impact. is what they call a fern spike. Ferns could grow quickly in the disturbed, ash-covered soil. But what about animals? The only creatures that survived were small. Most mammals at this time were no bigger than a raccoon, and many were the size of mice or shrews. These little animals had been able to hide underground, burrow into the earth, and eat whatever they could find. Seeds, insects, dead plants, anything. With the dinosaurs gone, all those ecological niches were suddenly empty, and these small mammals began to spread out, to diversify, to grow larger. It took about 100,000 years before the planet really started to feel alive again. The climate stabilized, plants regrew, the oceans recovered their chemistry, and marine life returned. But to get back to the level of biodiversity that existed before the impact, that took around 10 million years. And in that new world, mammals became the dominant life forms. Eventually, they evolved into everything we see today, including us. There's a direct line from that asteroid hitting the Gulf of Mexico 66 million years ago to you reading these words right now. If that rock had missed Earth, if it had arrived just a few minutes earlier or later and hit somewhere else, the dinosaurs might still be here. And mammals, including our ancestors, might have stayed small nocturnal creatures, hiding in the shadows forever. That single event, that moment of cosmic bad luck, completely reset the course of evolution on this planet. But here's the most important takeaway from this entire story. The explosion wasn't what killed them. The immediate disaster, as catastrophic as it was with the fires and earthquakes and tsunamis that killed maybe 25% of life on Earth. Terrible, but not an extinction-level event by itself. The real killer was what came after. The long-term climate change, the years of darkness and cold, the collapse of the food chain from the bottom up, the acid rain that lasted for years. It was the slow, grinding, unavoidable consequences that wiped out 75% of all species. The dinosaurs survived the worst day in Earth's history. What they couldn't survive was the worst decade that followed, the worst century, the complete transformation of their world into something they couldn't adapt to. 165 million years of dominance, an empire beyond anything we can imagine. And it all ended because one rock from space hit one specific spot on Earth at one specific moment in time and triggered a chain reaction of disasters that the planet couldn't stop. It's a reminder that no matter how powerful, how successful, how perfectly adapted you are, everything can change in an instant, and it's not always the shock that destroys you. Sometimes it's the slow unraveling that follows.